Have you ever looked at a map and seen a blank space? A place that seems empty, forgotten, perhaps intentionally left alone. These are not just wastelands, they are landscapes that hold a profound and unsettling secret. Places that once felt the heat of a man-made sun, an explosion so powerful it could shake the very foundations of our world. We are drawn to mysteries, to the stories hidden in the quiet corners of our planet. These sites, once the epicenters of incredible power, now whisper tales of science, ambition, consequence. They are silent monuments to an age when humanity unlocked the atom's core and forever changed its own destiny. Imagine a power so immense it could be seen from space, a force that could turn sand into glass in the blink of an eye. This is not science fiction. This was the reality in select, isolated corners of our globe. From the arid deserts of Nevada to the serene atolls of the Pacific Ocean, humanity conducted experiments on a scale that is difficult to comprehend. These were the proving grounds for the most destructive weapons ever conceived. Today, fences and warning signs guard these territories, marking them as forbidden ground. But what really happened there? What story do these silent, irradiated lands have to tell us about ourselves and our journey through the cosmos? What was nuclear testing? At its core, it was a scientific experiment, but it was an experiment born from fear and fueled by a global rivalry. After the first atomic bombs were developed during the Second World War, a new era began, the Cold War. The world's superpowers found themselves locked in a tense standoff. United States, Soviet Union. Neither side wanted to risk a direct conflict, so they competed in other ways. They raced to the moon, they competed in the Olympics, they raced to build bigger, better, and more numerous nuclear weapons. It was a contest of ultimate power, a show of force meant to deter the other side. To build these weapons, you first had to test them. Scientists needed to know if their designs would work. Would the bomb detonate? How big would the explosion be? How could they make it more efficient? How could they make it more powerful? Nuclear testing was the only way to answer these questions. It was a process of trial and error on a terrifying scale. The tests were also a form of communication, a way for one nation to send a clear, earth-shaking message to another. Look what we can do, do not challenge us. Where did this atomic drama unfold? The locations were chosen for their remoteness, places far from the prying eyes of the public and supposedly far from major population centers. In the United States, the primary stage was the Nevada test site, Yucca Flat, overlapping moon-like craters, a vast expanse of desert north of Las Vegas. Here over 900 nuclear tests took place. The iconic mushroom clouds were once a tourist attraction, visible from the city's hotels. The landscape is now pockmarked with hundreds of subsidence craters, giant sunken bowls in the earth where underground tests caused the ground to collapse. Half a world away, the Soviet Union had its own equivalent, the Semipalatinsk test site, known as the Polygon, an immense territory roughly the size of a small country. Nearly 500 tests were conducted here, many of them in the atmosphere during the early years. The land was not empty. Hundreds of thousands of people lived in villages and towns surrounding the site. The idyllic beauty of the Pacific Ocean also became a backdrop for these powerful detonations. The United States used the Marshall Islands, Bikini Atoll, Enuitak Atoll. These coral reefs, once teeming with life, were vaporized by hydrogen bombs 1,000 times more powerful than the one dropped on Hiroshima. What happens to a place after a nuclear bomb explodes? The immediate effects are obvious and catastrophic. A blinding flash of light, an intense wave of heat, a devastating shockwave that can flatten everything for miles. But the most insidious impact is the one you cannot see, hear, or feel at first. This is the fallout. When a nuclear weapon detonates, it vaporizes everything in its immediate vicinity. The soil, the rock, the tower it sat on. The blast sucks that material high into the atmosphere, into the mushroom cloud. That material becomes intensely radioactive. As the cloud cools and drifts on the wind, fine invisible dust begins to fall. Radioactive dust settles on everything. It contaminates the soil, unsafe to grow food. It lands in rivers, it lands in lakes, it lands in oceans. It poisons the water supply and aquatic life. Animals graze on contaminated grass. Radiation accumulates in their bodies. This is how the poison enters the food chain. For people living downwind, fallout became a daily invisible threat. They drank milk from contaminated cows, they ate vegetables grown in radioactive soil, they breathed dust on the wind, unaware. The danger of a nuclear test site does not end when testing stops. That's when the true long-term danger begins. Radioactivity is the problem. The elements created in an explosion include cesium-137, strontium-90, plutonium-239. They don't simply disappear, they decay very slowly. Plutonium-239 is one of the most dangerous substances. It has a half-life of over 24,000 years. So half its radioactivity lasts 24,000 years. The poison left in the ground is effectively permanent. That lingering radiation is a constant threat. It can be stirred up by wind. Contaminated dust can travel for miles. Rain can wash contamination into groundwater, and it can slowly seep into aquifers used for drinking or farming. Some sites, like the Nevada test site, remain heavily contaminated. Large areas are considered permanent sacrifice zones. They can never be safely inhabited or used. The threat will outlast any government, nation, or language. How do you warn future generations about something they can't see? We've created a poison that never sleeps. What do these places look like today? Decades after the last mushroom cloud faded, the nuclear test sites have become some of the strangest and most surreal landscapes on our planet. The Nevada test site, now called the Nevada National Security Site, is a place of stark, desolate beauty. The desert has begun to reclaim the land, with sagebrush and desert grasses growing around the edges of the immense craters, yet remnants of the atomic age are everywhere. Twisted metal towers, crumbling concrete bunkers, abandoned equipment, rusting under the desert sun. It is a ghost town not of people, but of an entire era of scientific ambition. In Kazakhstan, the Semipalatinsk polygon is a vast, open plain, eerily quiet. The central area, known as the Atomic Lake, is a crater formed by a massive explosion to create a reservoir. The water in the lake is still highly radioactive. Concrete towers that look like abstract sculptures. Shells of buildings built to test blast effects on a city. It is a landscape frozen in time. The Bikini and Enuitak atolls in the Marshall Islands present a different paradox. From a distance they look like tropical paradises. White sand beaches, turquoise waters, lush green palm trees, but this beauty is a facade. The vegetation has grown back, but it is radioactive. What can we learn from these forgotten places? They are more than just relics of a bygone era. They are powerful teachers, offering profound lessons about science power, our responsibility to the planet. The first lesson is one of humility. The scientists who began the atomic age were brilliant, but they could not foresee all the consequences of their work. They unlocked a power they could not fully control, and the legacy of fallout and long-term contamination is a stark reminder that our knowledge always has limits. Another lesson is etched into the very soil of these places, the interconnectedness of all things. An explosion in a remote desert did not stay in that desert. The wind carried its invisible poison across continents and oceans. Radiation that fell on a remote atoll entered the food chain and spread through the vast ecosystem of the Pacific. These sites prove there is no away. They are a powerful argument for a global perspective. One atmosphere, one ocean, one planet. In the decades since the tests, life has begun to return. Hardy desert plants push their way through contaminated soil. They are stories of survival, of advocacy, and of a deep desire to heal and ensure such a tragedy never happens again. They are a warning, etched in glass and dust, that we must never forget the power we hold in our hands. As we stand at the edge of these forbidden zones looking out over the craters, the silent, empty landscapes, we are left with a profound question. What is the future of these lands? They will not be returned to their former state in any human lifetime. The plutonium will remain for tens of thousands of years. They are, in a sense, a new kind of geological feature, a permanent mark of the Anthropocene, the age of humans. They may one day become strange archaeological sites where future civilizations try to decipher the meaning of twisted, steel-poisoned earth. Will they always be places of danger, fenced off, forgotten? Or can they be transformed into something more? Some have proposed turning them into memorials, places of reflection and education, where future generations can learn about the history of the atomic age. Others see them as unique scientific laboratories. The story of nuclear test sites is ultimately a human story. It is a story about our capacity for brilliant innovation, our capacity for devastating destruction. In the end, these lands are part of our shared global heritage. They challenge us to be better stewards of our planet and to think deeply about the technologies we create. A responsibility to our planet, to all the generations yet to come.